Okay, this video is going to be a pretty basic one. What we're going to concentrate on is how do we change between degree measurements and radians. And this is kind of leading us into something that we're going to be talking about down the road called the unit circle. Okay, so all that we're going to have to do for today's lesson is if I give you something in degrees, can you convert it to radian measure? And conversely, if I give you something in radian measure, can you convert it to degrees? Now, back in geometry, we learned this idea that a central angle, remember that's an angle whose vertex is at the center of the circle, all right, is equal to its intercepted arc, all right? And we talked in geometry about degrees. So for instance, if this angle, the central angle here was 45 degrees, then this arc would also be 45 degrees. And that's one way to measure the length of an arc, okay? But that's in a unit that is called degrees. Just like we know one trip all the way around the circle is 360 degrees. But then in geometry, we also talked about the circumference of a circle and actually taking that rim of the circle and stretching it out and being able to measure it. That's the circumference. And we learned a formula for circumference of a circle that said the circumference, let me write this down, that the circumference of a circle is equal to d pi. All right? Now, here's one thing that we also learned. We learned that the circumference was equal to 2 times the radius times pi. All right? Now, we're going to assume something here that we have a circle with a radius of 1, which tells us that one trip around the circle is going to be what is called 2 pi radians. So one trip around the circle is 360 degrees still. But in a radian measure, it's 2 pi units. Okay? Which means that halfway around the circle, or a semicircle as we learned, would be pi radians. Okay? Now, what this leads us to is the availability of being able to write a proportion that relates radians and degrees, and that's d over 180 is equal to r over pi, okay? And that's a way that we can kind of set up a proportion and cross multiply, but the way that I prefer to do the conversions is very simply this. If I'm going to go from degrees to radians, I'm going to multiply the given amount by pi over 180. All right? If I'm going to go from radians to degrees, I'm going to multiply the given radian amount by 180 over pi. So let me show you exactly what I'm talking about. And this should be pretty simple of an exercise. All that we're going to focus on really here, guys, is can you simplify fractions? And remember, we have that quick way to do it on a graphing calculator. If I need to, I might even pop that up here. It says we're going to convert each degree measure into radians. So we're going to have an angle that is of degree 285, and I want to change it into radians. So the way that I do that is I'm going to multiply by pi over 180. That multiplication converts it to a radian measure. And this would be 285 pi over 180. However, this is something that can be simplified. So if I take 285 and divide that by 180, notice I didn't say anything about pi. Pi has to remain in the answer. And I convert that, I know that this 285 degrees is the same as 19 pi over 12. So in radians, it would be 19 pi over 12. What about a negative angle? Now we're going to be talking about these in the next couple of lessons. But what if we have a negative angle? Well, negative angles do exist first. In order to convert a negative angle into radians, negative degree into radians, we still just multiply by pi over 180. And that would leave me with negative 340 pi over 180. And if I simplify negative 340 divided by 180, and I convert that into a fraction, I get negative 17 pi over 9 radians. All right? So notice, because we multiplied by pi over 180, we change these into radian measure. All right, and if you think about that 19 over 12 pi, what that's telling you is you went a little bit more than 180 degrees, but not as far as 360 degrees. So that would be close to like maybe 3/4 of a circle going around the rim in radian measure. All right, and like I said, we're going to be talking about degrees and radians a lot this week to get you guys to understand it. This is just kind of a good warm-up exercise. So the second thing that we got to be able to do here is if I give you a measurement in radians, can you change it into degrees? So when I was going from degrees to radians, I multiplied by pi over 180. When I'm going from radians to degrees, I'm going to multiply by 180 over pi. All right, I'm just going to go ahead and do that for both of these to start us off. Now, if you think about it, here's kind of the trick here. It doesn't work 100% of the time. However, we know that degrees, we've never seen pi as part of a degree measure. So really what I'm looking to do here is cancel the pi's out. That's how I keep it straight in my head, whether to multiply by 180 over pi or pi over 180. If I multiply a radian measure by 180 over pi, the pi's cancel out. So when I do that, I have negative 5 times 180, which would be negative 900 over 6 degrees. The pi's, again, canceled out. So if I take that negative 900 divided by 6, that would tell me that this is a negative 150 degree angle. And again, remember, what this is telling me, big picture here, is negative 5 pi over 6 in radian measure is the same as negative 150 degrees in degree measure. They are the same thing. They're just two different ways to measure it. All right, so if we convert this radian measure, 5 pi over 4, into degrees, we'd multiply by 180 over pi, which would give me 900 over 4, because the pi's would cancel out. And if I take 900 divided by 4, I know that this would be 225 degrees. So we now know that 5 pi over 4 in radian measure is the same as 225 degrees. All right? And 225 degrees is your answer. All right? Starting off simple here. Hopefully this helps. Let me know if you guys have any questions.